All right, let's dive right in. We are on the verge of a massive shift in medical research, one that could literally unlock decades of hidden data and completely change how we study diseases. This is big stuff. So, we're going to start with a pretty provocative question, right? Is the slow, incredibly expensive, and let's be honest, painstaking process of manually reading patient charts finally over? For years, it's been the gold standard, sure, but it's also been a massive roadblock to progress. You see, the problem has never, ever been a shortage of information. Hospitals are sitting on absolute mountains of data inside their electronic health records. No, the real bottleneck, the thing that slows everything down, is the staggering cost and time it takes to make sense of it all. And that brings us to this really crucial concept called dark data. Just think of it as all the rich, detailed human information that doesn't fit neatly into a spreadsheet. It's the real story of a patient's health journey, but it's been locked away in messy, unstructured text. It's been almost impossible to analyze at any kind of scale. So, what did we do to try and solve this before? Well, let's take a look at the first attempts to automate this, and you'll see pretty quickly why they kinda hit a wall. The first wave of automation used these really rigid, rule-based programs. The idea was simple. You give a computer a strict set of instructions, If you see this exact word, grab it. If you see that exact phrase, classify it. But clinical language is, well, it's messy. It's full of slang, typos, and a million different ways of saying the same thing. And that's where this whole approach just falls apart. And this comparison just lays it all out perfectly. On the left, you've got the old way. These systems are brittle. They break the second a doctor uses a slightly different phrase or makes a typo. They need endless, super expensive fine-tuning. But on the right, well, that's the new world. Large language models. They're flexible, they get the nuance, and they can actually understand the story being told in the clinical notes. So this is the breakthrough. We're moving beyond just matching words on a page to something that feels a whole lot more like genuine understanding. It's like the AI finally learned how to actually read. What's so fascinating here is this idea of the tacit knowledge gap. That's all the implied meaning and context that a human expert just gets when they read a chart. It's the stuff that isn't explicitly written down. Older programs could never grasp this, but the new AI models, they can. They can read between the lines, closing that gap and figuring out what was meant, not just what was typed. Okay, but that's the theory. Where's the proof? Well, let's look at the hard evidence. Because a landmark study published in Communications Medicine put this new AI to the ultimate test. The researchers basically set up a showdown, a head-to-head competition. They took almost 50,000 clinical notes from patients with Crohn's disease, and they gave 3 groups a challenge: extract some really complex clinical details. In one corner, you have a team of human experts. In another, the classic rule-based AI, and the challenger, GPT-4. And the results were just stunning. I mean, look at this chart. The performance of the human experts, that's our gold standard, way up there at the top. The old rule-based system, yikes, it struggled, way down at the bottom. But then look at GPT-4. It is right there, practically neck and neck with the humans. To put a hard number on it, GPT-4 hit an F1 score, which is just a measure of accuracy, of over 0.90. Now, this isn't just good for a computer. This is statistically the same performance as highly trained human specialists. It's incredible. The study's own conclusion really says it all. I'm just going to read this directly. There is no statistical evidence for a difference to the performance of human experts on this task. I mean, wow, that is a watershed moment right there. So what does this actually mean for the real world? This isn't just some academic exercise. This is creating a brand new reality for how medical research gets done. The most important takeaway is that this unlocks our ability to do research at a scale we could only dream of before. Think about it. Studies that would have taken years and millions of dollars for manual chart review can now, potentially, be done in a fraction of the time and for a fraction of the cost. So this ushers in a totally new way of working. And it's not about replacing humans. It's about augmenting them. The AI does all the heavy lifting, scanning thousands and thousands of charts. And then the human experts get to shift into a much more valuable role, validating the AI's work, focusing on the tricky edge cases and making sure everything is perfect. The result? A massive, high-quality dataset ready for analysis. And all of this brings us to our final and maybe the most important point about this incredible leap forward. When you look at all this evidence, continuing to rely only on manual chart review for everything, well, it's no longer the only game in town. It's not a necessity anymore. It has become an active choice. And frankly, it's a choice with massive costs. And we're not just talking about money and time. We're talking about the potential cures, the new treatments, the discoveries that we might be leaving on the table by not using these incredibly powerful new tools. So I'll just leave you with this question. For decades, countless breakthroughs have been locked away inside all of that dark data. Now that we finally have the key, what incredible discoveries are just sitting there, waiting for us to finally read them?